it says that we have lead ion, lead 2 plus ion. Okay, it says that we have iodate. Okay, the ion iodate, IO3 minus, and all this is producing PbO2 and iodine as the atomic molecule. Okay, so first of all, what we need to do, the first step is to get the oxidation state of each element that is in the compound. So I'm going to start with lead 2 plus. The oxidation state is specified right here, so you don't really need to calculate anything over there. So just write that the oxidation state is positive 2. Now we move into IO3 minus. It is an ion, also an ion, but this is a polyatomic ion. So how can we get easily the charge of iodine? You know the charge of oxygen is negative 2, okay? How can we get easily the charge of iodine? I get the charge of all the oxygen, which is negative 2 and 3, and then I add the charge. In that case it's negative 1, but I put it positive. So this gives me negative 5. Then, to balance this sign, I get rid of the negative, and this gives me the charge of iodine. Now, you can do it like that, but if you don't feel too confident, you can also get it with the equation, okay? You can say 1 iodine plus 3 oxygens equals to negative 1, okay? And then you can isolate for iodine. The charge of oxygen, you know, is negative 2. So iodine is going to be like this, and the negative 6 is going to go to the other side by adding, and then iodine, you will see that is positive 5. So it doesn't matter what procedure you do, in the end the answer will be the same. This is the most important part, okay? It doesn't matter how you do it. Now it is important that you also save time. That's why I'm doing this, okay? That's why I explain you in the 2 ways. But if you don't feel confident, just know that you can still use this procedure. It's valid, okay? Even if it takes longer, it's still valid. I will erase it since I know that you know how to do it. Also this one. And I will continue with the rest. I know the rule for oxygen, that is negative 2. So what is the charge that I need my lead to have, sorry. What is the charge that I need lead to have?
4.
4. I know that here it is very confusing because you see this 2 and you think, no, it is lead 2. But that is incorrect. Because if it was lead 2, remember that when you combine it with oxygen, which is 2 minus, the charges are cancelled. So no subscript is written. But here is different. You see a subscript, and that's why we get the oxidation number. It's not assuming the charge, it's calculating the charge. And then iodine on combined diatomic. What is the oxidation number for it? Oxidation number for combined elements?
0.
0. Okay? And with this you have all the oxidation numbers that you need. Now, what element is being reduced? What element is being reduced?
Iodine.
Iodine. Okay. it's being reduced, okay? Therefore, what element is being oxidized?
Lead.
Lead is coming from lead 2 to lead 4. So actually, lead is the one that is being oxidized. Okay, that's the most important step. Then you get your redox apart and you start working with the half reactions. But here we're going to write the entire compound or polyatomic ion. So reduction occurs in iodate, which is IO3 negative, and this is producing pure iodine. Now, I want us to work with the first reaction, so I'm gonna leave this apart. Let's focus on this. First of all, in the half reactions, we are going to balance all the elements that are in here. You have iodine and you have oxygen. You have one iodine in the reactant and you have two iodines in the product. What number I need to put in front of iodate to balance the amount of iodines?
2.
2. So you put 2 right there. Take a look, that's why I'm doing this example. I'm balancing the amount of iodines. So I put 2 in front, and now my iodine is balanced, but also my oxygen is 6. Now, how do I balance the amount of oxygens in the product? How much water I need to add? How much water I need to add? You add water as much as oxygens you need. If you need oxygen to be 6, you're going to add 6 waters. So you would add 6 waters like that. But including now water puts hydrogen in the equation that wasn't before. Okay, so now hydrogen is going to be listed here, and you have 12 hydrogens in the product. How many hydrogen plus ions must be added in the reactants?
12.
12. Okay, so you will say plus 12 H plus ions. And this is how we balance the reaction. Now, this is balanced by elements, but now we need to balance the charges. Now, to balance the charges, here in the iodate, I have 2 iodates that have a charge of -1. Okay? 2 iodates are transformed into this. 2 times the entire charge. 2 times the entire charge. Okay? Now, in hydrogen, I have 12 hydrogens, and the charge is plus. So that means that the charge is +1. Okay? This is producing 0, okay, because we have a pure element, so the charge over there is 0, and water is a compound, so the entire oxidation state of the compound is equalized to 0. So in here you have -2 plus 12 producing 0. Okay, so this is going to give me 10. The charge in my reactant is 10. That means that I need to add how many electrons?
10.
10 electrons. Now, where do we add electrons in the reduction equation? In the reactants or in the product?
Product.
In the reactants. Electrons are in the reactant. Or you can just I know that it looks like I need to add the 10 electrons here to for it to be balanced. I know that's how it looks. But remember that the charge of one electron is negative. Okay? So when you add 10 electrons in the end, you are saying that you are adding 10 plus 10 times negative 1, and this is going to be 10 minus 10, 0, producing 0. So that's why we add the electrons in the reactants. Where you have the number, in that part, you're going to add the electrons. So you have the 10 in the reactants. In this side, you will add the electrons. Okay? So these electrons from here, you need to write them in the half reaction. So you say 10 electrons plus the rest of the equation. Now, I don't know if you want me to leave all this procedure here. For me, it looks messy. But if you want me to leave it there, I'll leave it. Let me know in the chat. Once I finish with my reduction, I continue with my oxidation. Okay? I continue with my oxidation. My oxidation occurs between lead that is producing lead fourth oxide. That is my oxidation reaction, half reaction. Okay? So, take a look. I'm going to list the elements. I have one lead in the reactants and I have one lead in the products. So lead is balanced. Now oxygen, I have nothing here, but I have 2 in the products. So how much water I need to add?
2.
In the reactants or in the products?
Reactant.
Plus 2 waters. Okay. And now I don't have 0 oxygen, now I have 2 oxygens. But this brings hydrogen to the equation, so I list my amount of hydrogens. Now I have 4 hydrogens, so I need to add 4 H plus ions in the product for it to be balanced. And with this, I balance my amount of hydrogens. Now my equation is balanced, but I need to see the charges. So I have invisible 1 here. So I have invisible 1 times the charge of lead, which is plus 2, plus 0 from the water. Remember, entire compounds, the total charge of a compound is 0. Okay? That's why that one is a compound, so it's 0. This one is also a compound, so it's going to be 0. Plus, I have 4 hydrogens that have a charge of positive 1. So I have 2 plus 0 equals 2, producing 4. Now, how much or how many hydrogen I need to subtract from the products for this to be balanced?
Two.
Okay, 2. So, if I add 2 electrons here, I'm saying that 4 plus 2 times negative 1 is going to be equal, or it must be equal to 2. Let's see if it makes sense. This will give me 4 minus 2. So in the end, 2 will be equal to 2. So the amount of electrons that I need to add in my half reaction is 2 electrons in the product. Okay? So we say 2 electrons. Another way to do that, if you find this confusing, what you can do is you're working here, okay? So you can say 4 minus 2 is going to give you 2, okay? This is going to make 0 this side of the equation, and the other side is going to give me 2, okay? So from this number, I need to add the same amount of electrons. Plus 2 electrons to make it 0. So 0 is going to be 2 plus 2 times negative 1. 2 minus 2, 0, producing 0. You can do it in the two ways. Now, I don't do all this process. I just see that mentally, if I leave it like that, this gives me the amount of electron, that's all I need. I don't need to go on, okay? I'm just showing you all the process. So right now I have my two equations. They look in a very big mess, so I'm going to take them apart, okay? I'm going to take just my reduction and oxidation reactions apart, so we can work with the following steps. Okay. Now take a look to this equation. I'm gonna get rid of the. Okay. Now take a look to this. I have 10 up and I have 2 down. Okay, I want my electrons to be the same number. So by what number I need to multiply the second equation to have 10 electrons? Remember that I want these values to be the same. So by what number I have to multiply the second equation to have 10?
5.
Times 5. So I say I'm going to multiply times 5, okay? And then I will copy the result. Okay, so if I multiply times 5, these are going to be the coefficients, okay? Invisible 1 times 5 is going to give me 5. Invisible 2 times 5 is going to give me 10. Invisible 1 times 5 is going to give me 5. 5 times 4 is going to give me 20. And 2 and 5 is going to give me 10 electrons. What I do now is I add everything. I can directly cancel the electrons, okay? Because I have the same 10 electrons in the reactants and 10 electrons in the product. So what I can do is I can cancel them because they are the same number and they are located in the opposite sides of the reaction. So I'm going to get rid of the 10 electrons. And this is not updating. Amazing. Okay, now it's updating. So, you cancel the number of electrons. Okay, and you add everything. You add the two equations. So you say 2 iodate plus 12H plus 5 PV2 plus 10 waters. This is producing what I have in the right. That is iodine alone plus 6 waters plus 5 lead peroxide plus 20 H plus ions. That's my total amount. So now I start by canceling or forming water. In this case, I need to see what I have in common in the two sides. As you can see, I have H plus and H plus. What's the difference between them? Between 12 and 20? What is the difference? Between 12 and 20, what is the difference? What is the subtraction?
8.
8. So, you're going to subtract, okay? And the result is 8. So you are subtracting 12 minus 12 H plus because you want to cancel this number, okay? The result here you get, as you say, 8H plus. Now about water, I have water here and I have water also there. So I'm going to subtract the least number. So I say minus 6 waters, minus 6 waters. So this water right here is being cancelled. The result of this subtraction in the reactant is going to give me 4 waters. Okay. So right now all I'm going to do is I'm going to put down the remaining parts of the reaction. It's going to copy. Okay. So here I'm going to have 2 iodate plus 5 lead 2 plus the 4 waters. All this producing iodine plus 5 lead 4 oxide plus H plus. Okay. I know it's a long process, but if you follow it in the same order, everything is going to be just fine. Now, from this part is where the basic solution begins. You can indicate it or not, but when you begin with the basic procedure, that means that in the place that you're going to see how much H plus ions you have. Okay? So in here you notice that you have 8 H plus ions. In basic solution, what you have to do, you need to add the same amount, but hydroxide ions. Hydroxide ions. Okay? So you're going to add the same amount but hydroxide ions, which is OH minus. But whatever you do in the right must be done in the left. So you're going to copy also the 8 OH minus in the reactant, like that. Now, the rule says that whenever you have H plus and OH together, you can combine them to form water. Okay, so these 8 H plus and OH minus, actually they are going to create water. Okay, how much water? The same as the coefficient. The coefficient is 8, so you're gonna have 8 waters. And you copy the rest of the equation. Because I'm a lazy person, I'm just going to copy and paste. I'm sorry I don't allow you to be this lazy, okay? Now take a look in here. Now you will notice that water is in the two sides of the equation. You have water right here, and you have water also here. So again, what we do is, because they are in opposite sides, you're going to subtract the water. So you're going to subtract so this is going to be cancelled. This is going to be cancelled, but this one is going to give you a result. 8 minus 4 is going to give you 4 waters. So you copy the rest of the equation. And you're going to have all this. Okay? Sorry. So from this equation, now the last part is see if it's, the procedure ends here, but in the last part, what you have to do is check that it is balanced. So you compare PV, you compare I, O, H and O. You will notice that you have the same amount in the two sides of the equation. For example, here you have 5 and 5. Iodine, you have 2 and 2. Hydrogen, you have 8, and also in the other side you have 8. And oxygen, you have 8 plus 6, which makes 14. Also in the other side you have 10 plus 4, that makes 14. And with this you compare, that is balanced. Now the last part that comes is checking. This is the atoms. Now you check the amount of charges. The charges must be also equal. So you have 8 hydroxide, which is 8 times minus 1. 2 iodate, that is 2 times negative 1. And you have 5 lead,